Okay, here's the second example of how to solve absolute value inequalities by graphing. And you will notice that this equation looks familiar because we did this in example 1, but we're going to use the same technique that we did on the last example by solving it with graphing on paper, that is. We're going to turn this into an equal sign. So the first thing we have to do, though, is we have to get rid of this -2. The whole left-hand side has to be an absolute value in order to use this method, and here we've got this -2. So we'll add 2 to both sides, and then at this point I'm going to move over here a little bit. So I have 2 minus 0.5x less than or equal to 3. Okay, the whole left-hand side is absolute value, less than or equal to 3. Now at this point, I'm going to rewrite this 2 minus 0.5x, all that is absolute value, equal to 3. So I kind of just arbitrarily get rid of the absolute value, the inequality, and make that an equal sign. Now I can split this apart into 2 equations. So this becomes 2 minus 0.5x, there's a point there, equals 3. The right-hand side becomes 2 minus 0.5x equals -3. And these look just like what we did in example 1c, so I'm going to skip the algebra part because you can get that in example 1c, and you're going to come up with x equals -2 here. And then when you solve this one the same way we did in example 1c, you're going to come up with x equals 10. All right. Now we'll pick up with the new part, the solve by graphing. Remember, all absolute value equations are a v. Let's just go ahead and draw our v. There's our absolute value. So this represents the function absolute value. I got to learn to make these little equal signs just a little bit further apart to use this drawing tool. There we go. So absolute value of 2 minus 0.5x, that's the v. And then this line right here, this horizontal line, represents, in this case now, 3. Y equals 3. Okay. And where those two pieces intersect, well, that's the point -2 and the point 10. So now let's go look at our inequality part. So here's the inequality. And that says, when is the absolute value less than or equal to 3? Well, let's go back to our blue. If this line right here represents y equals 3, then the values above that would be when y is greater than 3, such as 3.5 and 4, 5, so on and so forth. Values below that would be less than 3, such as 2, 1.5, -6, so on and so forth. So what this is saying here is, when is the absolute value part of the equation less than 3? Well, that's this part right here. This part of the equation that I've shaded in red, that is, for those values, it's less than 3. So see, and the shading part is very important here because that allows you to write the solution with interval notation, which we're going to do right now. So let's write the solution in interval notation. So the shaded part, notice, goes from -2 to +10. Brackets, parentheses, let's go figure that out. So here's our inequality symbol. It's a less than or equal to. Because it's a less than or equal to, we get brackets. And so that's how you solve an absolute value inequality, by first setting it equal, coming up with these boundary values, I call them sometimes, you can call them intersection points, and then draw yourself this little mini graph sketch right here. Shade in the part of the absolute value that solves the inequality, and then you're ready to write in interval notation the solution.